Tutorial 1, you built an agent that takes a prompt and returns code. Text in, text out. Useful? Absolutely. But here's the problem, your hands are busy coding, your eyes are on the screen, and typing breaks flow. What if you could just talk to your agent and have it talk back? That's exactly what we're building today. A voice agent that listens with faster whisper, thinks with DeepSeek, and speaks with edge-tts. No cloud APIs. No monthly subscriptions. Just Python, a mic, and open source. Here's the architecture. 3 components in a loop. First, faster whisper, open source speech-to-text from OpenAI's research team. Runs locally on your GPU or CPU. No internet needed. Second, DeepSeek API, same OpenAI-compatible endpoint from Tutorial 1. Takes your transcribed text, runs reasoning, returns a response. Third, edge-tts, Microsoft's text-to-speech engine. Free, local, produces natural-sounding speech. The loop keeps going until you say stop. Total cost? $0 for STT and TTS. DeepSeek's free credit covers everything else. Let's install. Single pip command, pip install faster whisper. That's it. It pulls in ctranslate 2 under the hood, a heavily optimized inference engine. The base model runs comfortably on 2 GB of RAM and transcribes faster than real-time on any modern CPU. For mic capture, we also need Sound Device and NumPy. Sound Device gives us cross-platform audio input, works on Windows, Mac, and Linux with 0 config. One gotcha, if you're on Windows, make sure your default microphone is set in sound settings, not the stereo mix device. That's the mistake that'll have you wondering why your agent hears nothing. Next, edge-tts. One line, pip install edge-tts. This taps into Microsoft's Azure Cognitive Services Edge server, completely free, no API key required, no account. 400 voices across 100 languages. We're using Christopher Neural, male, natural, professional tone. Run edge-tts, list voices to see everything available. Unlike local TTS engines like Koki, edge-tts requires internet for the first request, then caches. But the quality is indistinguishable from paid services. And it's fast, sub-second latency for short responses. Now the code. The listen function does 2 things, capture audio and transcribe it. For capture, we use Sound Device input stream. We record 5 seconds of audio at 16 kHz, that's the sample rate Whisper expects. Convert the samples to a NumPy array, and save as a 16-bit wave in memory using io.bytes.io. No temp files. Then load the faster whisper model. We use base size, which balances accuracy and speed at about 1.5 GB. The model reads the wave buffer and returns the transcribed text. Key detail, set language to English explicitly in the transcribe call. Without it, Whisper auto-detects, which adds half a second of latency. Also, beam size of 5 gives you the best accuracy to speed ratio. Drop it to 1 for even faster transcription. The think function is almost identical to Tutorial 1. We call DeepSeek's chat completions endpoint. The only change is the system prompt. We tell DeepSeek it's a voice agent, so responses should be concise. Voice is different from chat. If the LLM rambles for 30 seconds, your user walks away. So we enforce a token limit, max 150 tokens. That forces short, conversational replies. Temperature is set to 0.7 for natural variety without going off the rails. And we reuse the same OpenAI-compatible client from Tutorial 1, just the model name and base URL. The response comes back, we extract the message content, and return it. Speak function. This one's straightforward, edge-tts takes text, a voice name, and writes audio to a file. We use communicate with NUS Christopher Neural and save to a temporary MP3. Then play it back. On Windows, we use WinSound. On Mac or Linux, we can use the system's built-in audio player, fplay for Mac, apply for Linux. The important detail, rate equals plus 10%. The default speed feels too slow for conversation. A slight bump makes it sound natural. And we add a 50 millisecond gap using trim silence to avoid clipped first words. Without that, listeners miss the first syllable, especially on shorter responses like sure or okay. Now the main loop. This is where it gets real. While true, listen, think, speak. That's the entire voice agent. We call listen, it records 5 seconds of audio and transcribes it. Pass the text to think, DeepSeek returns a response. Pass the response to speak, edge-tts plays it out loud. Then the loop starts again. 2 quality of life features. First, wrap the listen call in a try except for keyboard interrupt. Control-C should exit cleanly. Second, add an exit phrase. If DeepSeek's response contains the word goodbye or if the transcribed text does, we break the loop. Users need a way to end the conversation naturally. Also note, async in the speak calls. edge-tts is async, so we wrap it with asyncio.run inside the synchronous loop. Python 3.10 and later handle this transparently. Let's see it in action. First question, what is faster whisper? 5 seconds of recording, 1 second to transcribe, 300 milliseconds for DeepSeek, 200 milliseconds for TTS. Total round trip, under 7 seconds. That's near real time. Second question, tell me a fun fact about space. Same pipeline, slightly longer response, still under 8 seconds total. And finally, goodbye, the agent recognizes the exit phrase and ends the conversation. No voice commands to remember. No wake words to set up. Just natural conversation flow. 3 extensions. First, memory. Right now each question is independent. Add a conversation history list, append each user message and assistant response. Pass 30 seconds worth to DeepSeek's messages array. Now your agent remembers context. What was that last thing you said? It knows. Second, tool calling. DeepSeek supports function calling. Define tools like get_weather or search_web. When the agent detects an intent, it returns a function call instead of text. Execute it, feed the result back, and let DeepSeek formulate the voice response. Third, a wake word. Instead of recording on a fixed 5-second timer, use a voice activity detector. Buffer audio until you detect speech, transcribe, respond. This gives you a truly hands-free agent that listens continuously. 3 functions. 1 loop. 0 cloud lock-in. You now have a production-grade voice agent that listens, thinks, and responds, all with open-source tools and DeepSeek's $5 free credit. The code is yours. The data stays local. The architecture scales from a laptop to a server. If this was useful, like the video, subscribe for tutorial 3, where we give the agent eyes with Quen's vision model. Full source code linked in the description. Go build something that talks back.